this video is going to show you guys how to solve a rational inequality, okay? Rational because you have a fraction where the denominator is an algebraic expression, okay? It has an x plus or minus some number, okay? There could be a coefficient here. Algebraic expressions, okay? So here we have algebraic expressions in the denominators, okay? Automatically we're gonna have a rational expression. And since it's an inequality, it's a rational inequality. How do we solve this, okay? So here's the first steps. Well, here's all of the steps actually. So let's kind of get through here. So I'm gonna take you over here. Okay, there's a lot of steps here. So please watch the organization, okay? Right now we have the original. That's what we had over there. 8 over x plus 6 is greater or equal x over x plus 3, okay? What happens here is that I told you guys, you always want to make one side equal to 0, okay? 0. So what was done here was the additive inverse. X over x plus 3, if I want to move this to the other side, I'll just do minus x over x plus 3. Over here, I'm going to do the same thing, right? What you do to one side, you must do to the other, okay? By the way, in the middle of this, sorry about that, in the middle, we still have the same symbol, okay? Greater or equal. Now, once you move this over, okay, there is a cancellation. It will cross out. So we look down here, you will end up with this right here. 8 over, so we have 8 over x plus 6 minus x over x plus 3, which is this right here. Sorry about this, a little slash. Gotta fix that. Okay, just to make it look good. So again, 8 over x plus 6 right here minus this is this same thing here. We just wrote it horizontally, okay? Because it looks better like that. Now I want you to notice something. On the right side, obviously, when you cross out the same terms, you have 0, okay? The same expression. So that side we have greater or equal to 0. So we took care of this part. This is important, okay? You want to have one side equal to 0. However, here we have how many fractions? 1, 2. We have 2 fractions, okay? So you look at the denominators and you say to yourself, how can I make x plus 3 have something with x plus 6 in it so that they both have the same denominators? X plus 6 and x plus 3 are not equivalent. They do not have any factors in common. Meaning what I need from x plus 6, okay, if I'm this fraction, I'm gonna need this entire factor because I don't have it. I only have myself. I need what you have, right? It's like 2 fractions borrowing from each other. This fraction needs what this fraction has, and this one needs what the other one has because they don't have anything in common, okay? So x plus 3 needs what? X plus 6, which is why we have here x plus 6 and x plus 6. Notice top and bottom. To the contrary, over here, we have x plus 3, top and bottom, because clearly x plus 6 does not have x plus 3. So we give it top and bottom. I want you to notice something. I circled here. You don't need, okay, you don't need to multiply down here, okay? You don't need to multiply those factors. Same thing over here. You do not need to multiply in the denominator. I don't recommend it because you will see that we're gonna need to, we need to find the zeros eventually of the bottom, okay, of the denominator. So don't multiply here, okay? However, where we should be distributing, like I said before, is up here in the numerators, over here in the numerators, okay? So what does that do? 8 times x is 8x. 8 times 3 is 24, okay? Plus 24. Careful with this negative here. When you subtract it, okay, when we did minus this, okay, and we have this here, minus, there's a minus there. However, since it's negative x times x plus 6, you have to distribute negative x. So that gave us here, let me just put a plus in the middle, okay? I'm putting a plus in the middle because now we know we're going to add them all together and we already took care of that negative. That negative is going inside. So we have negative x squared, negative x times 6, negative 6x, okay? Again, the right side is still greater or equal to 0. We don't have to touch this for a while, okay? Your goal is to turn 2 fractions, again, 2 fractions into 1 fraction. How did we do that? Well, look at the like terms here. We have 8x and negative 6x, which will give us positive 2x. Negative x squared doesn't give us any other like term up here. There's no other like term that will add up with negative x squared, so we leave it by itself. Positive 24 doesn't have any other like term, so we leave it as positive 24, okay? Look at the denominators. We did not multiply them out, okay? Same denominator, but we did not multiply them, okay? So now here is where a little bit of organization needs to be done, okay? What was done here was that we want to figure out where in the denominator will this become undefined, okay? Where will these factors equal 0? So here, x plus 3 is going to be 0 when x equals negative 3. X plus 6 is going to be 0, okay, when x is negative 6. So notice, these two guys here are my UDF, okay, my undefined. I want to show you up here that I basically copied this part, okay, and I put it right in the center, okay, I put it right back up there. Notice, I took these factors again, and I found my undefineds, right? X equals negative 3, x equals negative 6. I always put an open circle there because when we go to the number line, you will see that these values must have open circles on top of them, okay, for the solution set, for the number line. To the flip side, once you do that with the undefineds, right, what about the numerator? Do we just leave the numerator and finish the problem with the undefineds? No, you need the undefineds, but you also need to take the numerators and find the zeros, okay? Follow me here. So what was done here was we took the numerator, which is there, we set it equal to 0. Now, to solve this for the zeros, when we have a negative in front of x squared, it's just easier to factor the negative out, okay? We're normally used to factoring quadratics that have a positive coefficient, leading coefficient, so it's better to take out the negative, okay? When you remove the negative, you'll see that all of the signs will just change. Negative becomes positive, this becomes negative, positive becomes negative, positive becomes negative, okay? At this point, this looks like something more familiar, and you should probably be more comfortable factoring this than the original, okay? Here, that negative will not bother us at all when it comes to these factors, okay? So now let's get at this. We can factor this here. So 4 and negative 6 add up to negative 2 and multiply negative 24. So these are our factors. Again, we are setting them equal to 0. We wanted to figure out where is it equal to 0. So equals 0 equals 0. You can do the additive inverse on both sides. Our zeros, okay, our zeros are 6 and negative 4. Now, with the zeros and with the undefineds, look how I put them all together. What are those values called? Those are called together. These are our critical values, okay? Critical values. Okay, critical values. Where do the critical values go? 6, negative 4, negative 3, negative 6. They go right over here, okay? Our number line, okay? So by the way, definitely need a little bit of arrows. I'm going to clean that up. Definitely need a little bit of arrows, okay? And I want you to notice, between each of the critical values in red, negative 6, negative 4, negative 3, and 6, okay? Remember, they're coming from these guys, right? You want to put them in numerical order, okay? So negative 6 is less than negative 4, so it goes to the left, and vice versa, okay? Now, at this point, how do we test each interval, okay, to figure out the solution set? Well, remember, if you have 1, 2, 3, 4 critical values, you will have 1, right here, 1, 2, 3, 4, 5 intervals. 5 intervals. Okay, how do we test the values in each interval to see if it satisfies this right here, okay? So what I did was to just kind of be more efficient, like since we have the graphing calculators, and this is just a matter of efficiency, okay? You could do this by hand, but for the sake of time, right, since the exam, you have a period to do this, the efficient way would be here, okay? You're gonna graph this function in the calculator, okay? So to do this, again, you must use parentheses, okay? So I put parentheses, this is exactly what I entered in the calculator, okay? To enter this piece in the box, right? To enter this in the calculator, parentheses, negative x squared plus 2x plus 24. Close the parentheses. Divided by, open parentheses. You see the denominator here? Some of you might just want to put it by itself, like without this one and without this one. The calculator might make a mistake, so it's better to be safe than sorry. Open up a parentheses and now put this what you see here. So open parentheses, another one, x plus 3, close it. That's that. Then this one, open parentheses, x plus 6, close it, and close the big one, okay? So if you enter the buttons here directly in y equals, okay? So again, where is this going? This is going in y1 equals, okay? You put that in the graphing calculator, you will be able to have the table, the x and the y, right? You can see the table like we did in class. At that point, you will go and to each interval, select a x value in each interval and then test it, okay? So here, something less than -6, I picked -7. In the table, it gave me -9.75. I didn't even have to calculate it. It's already there for me. All you have to do is take the y value and ask yourself, is negative, so let me kind of, now that I don't need this anymore because it kind of leaked in, okay? Sorry about that. Is -9.75 greater than or equal to 0? Remember, the original right here, this is our test. Okay, right here we are testing with this, okay? I'm gonna put test. You're gonna test it with that. So every time you get a y value, ask yourself, is it greater than or equal to 0 for this inequality? The answer is no, it's not, right? Negative is definitely less. So since it's no, we don't include the interval. I put an x there, but I just erased it so that you see the answer is no. However, when a number between -6 and -4, -5, okay? When x is -5, okay? When x is -5, the y value from the, again, I have it in the table, tells me that it's 5.5, okay? And what does that mean? Is 5.5 greater than or equal to 0? Yep, yes it is. So since it is, look what I do. When it's yes, okay? When it is yes, I want you to connect, okay? When it is yes, I want you to connect. So we connect, okay, between here and here. Now, quick question. You might notice, right, so even before we look at the intervals, you might be noticing, like, why are some of them open and why are some of them closed, right? Good question. Look here what I did for you in the beginning. My undefined values, I always put that open circle there because I know that my undefined values will have an open circle. You never include them, no matter what. So -6 gets an open circle, and -3 gets an open circle. However, why would -4 and 6 have closed circles? Look at the test. The test says greater or equal to 0, okay? Since 4 and 6, -4 and 6 are my zeros, and the inequality says that I can include 0, shade it in, okay? Just for those of you who might have been wondering, why are some shaded, why aren't they? Undefineds never shade. The zeros right here, -4 and 6, okay, from the numerator, it depends on the test, okay? Because if this was like this, greater than 0, I would have to erase that. It would have to be open. Okay, we went over that in class also. Again, this interval checked out, it was yes. Now, between -3 and -4, here's where it's going to be a little tricky, right? What value can you try between -3 and -4 if the table doesn't give you the value, right? Well, the table won't give you the value right away. So what I'll do here is I'm going to try, between -3 and -4, why don't we try -3.5? That's basically right in the middle, okay? That's basically right in the middle of -3 and -4. So what we need to do here, we're going to use the calculator, okay? So let me show you how to do that on the calculator really quickly. So again, so let's take a look here what we have in here. So first off, there's no function. So here, actually, this is a good way for me to show you. I know this video is a little long, but let me, again, this is a good opportunity for me to enter the function here into the original, okay? So again, the function was like this, parentheses, right? X squared, sorry about that, negative x squared plus 2x plus 24, close it. Okay, sorry, close it. Now, again, divided by, hit the division button, divided by, now, parentheses, again, now I can put x plus 3, x plus 6 with its own stuff. So now, parentheses, see that? 2 parentheses. So, x plus 3 and x plus 6, 6, and I'm going to close it, okay? So when I go to second graph, right, when I go to the table, obviously between, again, look at where we are. We're looking for negative 3 and negative 4. Between negative 3 and 4, the table won't show you that right away, right? But here's a good trick. The trick is this. Go to your table set, okay? Your table set, you can change where you start, okay? So let's say I wanted to start at 3.5, okay? Negative 3.5. I can do that, and when I do that, look what happens. I go back to my table, and now I have the values like that I need in this case. So for negative 3.5, the y value is negative 3.8. See that right there? Is negative 3.8 greater than or equal to 0? No, okay? So you don't include there. Now to fix it, just go back. Second window, and now pick any number that's a whole number. So I'm just gonna press 0, okay? Like the usual. So I'm back in business, okay? Now, between negative 3 and 6, I need to pick an x value. Here on the board, I have picked 2.5, but the truth is, you can pick anything now from negative 3 to 6, okay? So you could have picked negative 2 and 4. You could have picked negative 1 and this y value. Anything up until 6, okay? So before 6. And notice, all of these y values are positive, okay? So, sorry about that. Wow, this looks complicated. A lot of asymptotes. So anyway, when we go back to the table, between negative 3 and 6, you will see that the answer is positive and it's yes. So you connect, okay? Finally, something greater than 6. On the board, I picked 6.5, okay? But on the table here, okay, when we go to something bigger than 6, look at all the y values. As soon as you go greater than 6, all of them are negative, okay? Is negative, any number negative, is it greater than or equal to 0? No, it's not. So you don't shade it in, okay? Again, this is a long problem. This might be maybe the tougher problem on the final. But make sure you watch this video a few times, practice by yourself, and I believe you'll be able to get it. Okay, guys?